Allahu Akbar. Allah.
Today, let's uncover the 11 most violent forces ever recorded on Earth. A volcanic blast so powerful, it sent a plume nearly 58 kilometers into the sky.
Here we go.
Another flattened 230 square miles of forest in seconds, triggering tsunamis across oceans. These were caught on camera, from Japan to Indonesia to the middle of the Pacific Ocean. Let's dive in. On May 18, 1980, at 8:32 a.m. Pacific Daylight Time, Mount St. Helens, a stratovolcano in Skamania County, Washington, in the Cascade Range, part of the Pacific Ring of Fire, erupted in one of the most powerful and destructive volcanic explosions in U.S. history. The eruption followed 2 months of unrest that included hundreds of small earthquakes and steam blast eruptions beginning on March 16 to 27, as magma moved beneath the volcano and created a bulge on its unstable north flank. A magnitude 5.1 earthquake triggered the largest landslide ever recorded, removing the north face and instantly depressurizing the magma system. This unleashed a lateral blast of superheated gas, ash and rock that surged outward at high speed, flattening forests across roughly 230 square miles and devastating the landscape up to 19 miles from the summit. A colossal vertical ash plume also rose about 24 kilometers into the atmosphere, spreading ash across much of the Pacific Northwest and even into Canada. The eruption produced lahars, volcanic mudflows from melting snow and ice, which surged down rivers and caused additional destruction. In total, 57 people were killed, including volcanologist David A. Johnston, and hundreds of square miles of forest, infrastructure, and ecosystems were destroyed, with damages exceeding $1 billion. The volcano's summit elevation dropped dramatically as a horseshoe-shaped crater formed, and pyroclastic flows, lahars and ashfall, reshaped the surrounding region. The eruption had profound impacts on volcanic monitoring, hazard communication, and scientific research, and the area has since been designated a national monument for ongoing study of ecological recovery and volcanic processes. Now, let's see what would happen if a volcano, without giving months' warning, erupted in the middle of a peaceful day. On 27 September 2014, Mount Ontake, a 3,067-meter stratovolcano on the island of Honshu in central Japan, erupted suddenly at about 11:52 a.m. local time, in a violent phreatic explosion that caught hundreds of hikers and tourists by surprise during a clear autumn weekend. The eruption produced multiple new craters, sent a dense ash plume rising 7 to 10 kilometers into the sky, and generated pyroclastic flows that traveled several kilometers down the volcano's slopes, scattering ash, rock, and steam into the surrounding area with virtually no clear long-term warning despite minor tremors detected shortly before the event. Because many visitors were near the summit enjoying hiking and sightseeing, the eruption was highly deadly. 63 people were confirmed killed, including several bodies never recovered, and many others were injured as hot rocks and gas hit climbers and ash covered the mountain and trails, prompting one of Japan's largest and most difficult rescue operations. The tragedy was the worst fatal volcanic eruption in Japan in recent decades, occurring without obvious precursors and illustrating the unpredictability of phreatic eruptions driven by underground water flashing to steam rather than fresh magma reaching the surface. Japan is not the only country that understands the danger of a sudden eruption. New Zealand has also faced an even more terrifying fate. On 9 December 2019, at approximately 2:11 p.m. local time, Whakaari White Island, New Zealand's most active volcano, erupted suddenly in a hydrothermal explosion while 47 people, mostly tourists and guides, were on the island. Whakaari is a small volcanic island located in the Bay of Plenty about 48 kilometers off the northeast coast of New Zealand's North Island. With roughly 70% of the volcano submerged underwater, and it has a long history of frequent activity, including near-continuous eruptions between 1975 and 2000. The eruption occurred when superheated water within the volcano's hydrothermal system rapidly flashed into steam, causing a violent pressure release that blasted ash, rock, and toxic gases into the air, sending a plume rising approximately 3 to 4 kilometers above the island and engulfing the crater area in seconds. The explosion lasted only a few minutes, leaving people little time to escape. Most victims were tourists, primarily from Australia, with others from the United States, New Zealand, Germany, China, and the United Kingdom. Following the disaster, all tourism to Whakaari was permanently halted, and the eruption led to major legal, regulatory, and scientific reassessments of volcanic risk management, particularly regarding public access to active volcanoes and the inherent unpredictability of phreatic eruptions, which often occur without clear seismic or deformation warnings because no new magma reaches the surface. Now, let's shift from tourist islands to one of the most volcanically dangerous regions on Earth. Mount Tavorver is an active stratovolcano located on the northeastern edge of the Rabaul caldera on the island of New Britain, part of Papua New Guinea, positioned between the Bismarck Sea to the north and the Solomon Sea to the south. The volcano has a long and destructive eruptive history that has repeatedly affected the surrounding Rabaul region, one of the most volcanically hazardous areas in the Southwest Pacific. In 1937, eruptions from Tavorver and the nearby Vulcan Cone killed more than 500 people. In 1994, renewed activity from Tavorver devastated the town of Rabaul, burying much of it in ash and forcing the permanent relocation of the provincial capital. Subsequent eruptions in 2006 produced powerful explosions, ash columns rising more than 18 kilometers, and shockwaves strong enough to shatter windows several kilometers away. On 29 August 2014, Tavorver erupted again, sending a dense ash plume high into the atmosphere and producing explosive blasts that were widely recorded on video from ships in Blanche Bay.
Here we go.
The eruption generated a visible shockwave, delayed thunder-like booms, and heavy ashfall that prompted evacuations in the Rabaul area and disrupted aviation, with ash clouds forcing flight diversions across parts of the Southwest Pacific. Although the eruption caused no mass casualties due to prior evacuations and improved monitoring, it revived memories of earlier disasters among residents. On 15 January 2022, the Tonga-Hunga Ha'apai volcano, a largely submarine volcano located in the South Pacific within the Kingdom of Tonga, erupted in an extraordinarily powerful explosive event that ranks among the most significant volcanic eruptions of the modern era. Tonga is an archipelago of more than 160 islands, with a population of just over 100,000 people, and the volcano lies roughly 65 kilometers north of the capital Nuku'alofa. The eruption followed weeks of escalating activity beginning in late 2021, and culminated in a colossal explosion that sent an ash, steam, and gas plume deep into the stratosphere, with satellite-based atmospheric measurements indicating material may have reached altitudes of up to roughly 58 kilometers, the highest plume ever directly observed by modern instruments. The blast generated powerful atmospheric shockwaves that circled the Earth multiple times and produced tsunamis across the Pacific, affecting Tonga, Japan, Chile, Peru, and the west coast of the Americas. In Tonga, ashfall contaminated drinking water, destroyed crops, damaged homes, severed communications, and displaced communities, while tsunami waves caused coastal destruction. The eruption obliterated much of the volcanic island itself and injected an unprecedented amount of water vapor into the stratosphere, prompting long-term scientific interest due to its potential climate effects. Officially classified as a VEI5 eruption, many volcanologists note that its energy output, plume height, and atmospheric impact place it at the extreme upper end of that category, with some arguing it borders VEI6 behavior, particularly for a submarine eruption. Sakurajima, whose name translates to Cherry Blossom Island, is one of Japan's most active volcanoes and lies in Kagoshima Bay at the southern tip of Kyushu, directly across from the city of Kagoshima. On November 16, 2025, the volcano produced multiple explosive eruptions from the Minamidake crater, sending ash and smoke very high into the atmosphere, reported at about 4,400 meters above the crater. These eruptions were powerful enough to disrupt air travel and cancel or delay dozens of flights at nearby Kagoshima Airport due to volcanic ash hazards, which can damage aircraft engines. Japanese authorities, maintained a volcanic alert level 3, warning people to stay clear of the crater zone and advising ashfall precautions in Kagoshima and neighboring regions. A consecutive explosive event on November 19, 2025, was documented by multiple local observers and volcanology channels. It produced a strong explosive eruption plume, rising 31,600 milliliters above the Minamidake crater. This occurred during what was described as the 156th explosive event of the year 2025. Situated along the Pacific Ring of Fire, Sakurajima exemplifies Japan's volcanic hazards, where persistent, relatively small eruptions pose ongoing risks from ashfall, volcanic bombs, and gas emissions, especially given the proximity of a major urban population living just a few kilometers from one of the world's most continuously active volcanoes. Would you feel safe living in a city just a few kilometers from a volcano that erupts hundreds of times a year? Let's discuss in the comments section, and don't forget to check out more interesting content in the top right corner of your screen. Speaking of legendary volcanoes, Krakatoa rewrote history, and its dangers didn't end with a single eruption. Also known as Krakatoa, is a volcanic caldera located in the Sunda Strait between the Indonesian islands of Java and Sumatra, an area shaped by the collision of the Indo-Australian and Eurasian tectonic plates. The volcano is infamous for its catastrophic 1883 eruption, one of the most violent volcanic events in recorded history, which caused massive tsunamis and killed an estimated 36,000 people, mostly along nearby coastlines. After that eruption destroyed most of the original island, a new volcanic cone, Anak Krakatau, meaning child of Krakatoa, began rising from the sea in 1927 and remained persistently active throughout the 20th and early 21st centuries. In 2018, Anak Krakatau entered an intensified eruptive phase, marked by frequent Strombolian explosions, lava fountains, and nighttime eruptions that were widely photographed and filmed, showing incandescent lava cascading down the volcano's flanks. This sustained activity destabilized the structure of the volcano, and on the evening of 22 December 2018, a large portion of Anak Krakatau's southwestern flank suddenly collapsed into the ocean, triggering a volcanic tsunami without the warning signs of an earthquake. The tsunami struck coastal communities along western Java and southern Sumatra, inundating beaches, resorts, and villages, killing more than 400 people and injuring thousands. Satellite imagery later revealed that Anak Krakatau had lost a significant part of its mass and height during the collapse. The event became the deadliest volcanically generated tsunami in Indonesia since 1883, highlighting the extreme dangers posed by unstable volcanic islands and demonstrating that even relatively moderate eruptions can produce devastating secondary hazards such as flank collapse and tsunamis. Now let's move to Italy. Mount Stromboli is a persistently active stratovolcano forming nearly the entirety of the small Italian island of Stromboli, one of the Aeolian Islands in the Tyrrhenian Sea north of Sicily, and it rises about 924 meters above sea level from a much larger volcanic structure on the seafloor. Known for its near-continuous mild explosions for at least the past 2 millennia, Stromboli has earned the nickname the Lighthouse of the Mediterranean. On 3 July 2019, a sudden paroxysmal explosion ejected volcanic bombs, ash, and pyroclastic material, killing a hiker near the summit and triggering fires across the island's slopes. This led Italian authorities to restrict access to the upper portions of the volcano. A second major eruptive episode occurred on 28 August 2019, when Stromboli produced another powerful explosion that sent an ash column roughly 2 kilometers into the air and generated pyroclastic flows that traveled down the steep northwest flank known as the Sierra del Fuoco, with some material entering the sea. Despite the intensity of the August eruption, no additional fatalities occurred due to rapid emergency response and existing evacuation plans. The events of 2019 highlighted that even volcanoes with long-standing, well-understood behavior can abruptly escalate into far more dangerous activity, reinforcing Stromboli's status as one of Europe's most closely monitored and potentially hazardous volcanoes. The Eyjafjallajökull volcano in southern Iceland erupted in 2010 after a substantial quiet period, beginning with intense seismic activity in late 2009 that culminated in an initial eruption on 20 March 2010 at a fissure on the volcano's northeast flank near Fimmvörðuháls, where lava flowed in relatively effusive, non-ash-producing eruptions. Soon after a brief lull, a much more explosive phase began on 14 April 2010 from the ice-covered summit caldera, where magma interacted with overlying glacier ice, melting it and fragmenting the magma into extremely fine ash. This interaction caused powerful explosive activity that sent an ash plume several kilometers into the atmosphere, with ash rising as high as around 9 kilometers, which was carried by winds southeast and east toward Europe. The volcanic ash cloud led to the closure of large swaths of European airspace from 15 April to at least 21 April 2010, and intermittently afterward, causing the largest disruption to commercial air travel in history, with more than 95,000 flights cancelled and about 10 million passengers affected as airlines worldwide suffered significant financial losses. Locally, the eruption generated meltwater floods, jökulhlaups, and required evacuations around the volcano, and its effects were felt far beyond Iceland due to atmospheric ash dispersal, economic impacts, environmental concerns, and changes to international aviation safety procedures regarding volcanic ash. The eruptive sequence tapered off by late May and was declared over later in 2010, although the region remains closely monitored for future activity. In 2015, the volcano Shindake on the small volcanic island of Kuchinourabujima in southwestern Japan underwent a significant eruptive episode that drew global attention. The island's roughly 147 residents live in a remote part of the Osumi Islands and rely on boat access, as there is no airport. Shindake is the youngest and most active vent on the island's volcanic complex, with all documented historic eruptions occurring from its summit crater, while the island itself has had many eruptions over the past 10,000 years. On 18 May 2015, scientists monitoring the volcano observed increased seismic activity and vigorous steam emission from Shindake's crater, signaling that pressure was building beneath the surface. 11 days later, on 29 May 2015, at about 09:59 local time, a powerful phreatomagmatic eruption occurred from Shindake's summit, sending a dense eruption column higher than 9 kilometers into the sky and producing pyroclastic density currents that swept outward from the crater. Volcanic ash fell across nearby areas, including Yakushima Island, and ballistic blocks from the eruption were scattered near the volcano. Thanks to the early seismic and fumarolic warnings, all island residents were safely evacuated by the Japan Coast Guard before the main explosion, avoiding fatalities. Only one minor injury was reported. The 2015 event was preceded by the August 2014 eruption, when pyroclastic flows traveled downslope, and later part of a series of repeated explosive events from Shindake, with continued seismic and ash activity recorded in subsequent years.
Allahu Akbar. Allah.
And finally, we end with a reminder of how fast everything can go wrong when a mountain collapses without warning. On 4 December 2021, Mount Semeru, the highest and one of the most active volcanoes on the Indonesian island of Java, produced one of its most significant and destructive eruptions in recent history, when a collapse of its summit lava dome occurred. It was likely triggered by heavy rainfall and destabilization of accumulated volcanic material, unleashing powerful pyroclastic flows and other explosive activity down its southeastern flanks. These hot avalanches of gas, ash, and debris devastated nearby communities in Lumajang Regency, East Java, burying homes, destroying infrastructure, including the Gladak Perak Bridge, and prompting mass evacuations. The eruption column and associated pyroclastic phenomena caused widespread ashfall and lahars, leading to the damage or destruction of at least 5,205 homes and several public buildings. In the aftermath, Indonesian disaster agencies reported dozens of fatalities, while more than 10,000 people were displaced or evacuated from high-risk areas as search and rescue operations continued. The eruption's sudden nature and rapid advance of pyroclastic material made it particularly dangerous for residents, underscoring both the ongoing hazard posed by Semeru's persistent activity and Indonesia's vulnerability due to its location on the convergent Sunda-Indo-Australian plate boundary. These 11 eruptions remind us that volcanoes are among the most awe-inspiring and unforgiving forces on our planet. Some gave warnings that scientists could track, while others erupted with terrifying speed, leaving little time to react. Whether captured from the air, from nearby cities, or by people who were tragically too close, each eruption shows how quickly the balance between beauty and destruction can shift. As technology improves and our understanding deepens, these events continue to shape how we study, respect, and coexist with the restless forces beneath our feet. If you enjoyed today's video, don't forget to hit like, subscribe, and turn on the notification bell so you won't miss our upcoming journeys. We hope you enjoyed this video as much as we enjoyed creating it. See you in the next video.